Good morning, dear friends. This is Yasura Singh. This is Yasura Singh speaking from Bharat, India, on this day of 22nd March 22nd, 2021, Monday. This is your friend. Usually, I give videos regarding profession of engineering, regarding issues related to profession, and regarding, relevance to quality designs, construction method statements, time, cost, risks, reliability. Quality is considered number one for everything. To consider quality designs means quality designs and construction, and we can say based on method statements, time, cost, risks, reliability, all results of that. How far can we move on such issues? Is a question here. How far? We cannot say that both are true. Since we are considering quality, number one, we have to deal with this in various ways in buildings. Products like ethylene plant, like alkali plant, or like whatever you can say. So many side plants, byproduct plants, and also you can say electrical power stations, gas-based or otherwise, or many other plants which are based on technology. And also buildings I'm talking of which are non-plants buildings, because in every plant there are plants buildings and non-plants buildings. There are various areas in every plant. Whole overall you can say it's a plant, but when you analyze that, you will find that there are so many areas. I would like to show you example of that was very important point which I'm discussing with you in that sketch. I'll discuss with you. That is, this is a sketch I'm going to open. It's a very important one for everybody. This is a sketch which I gave you. I just rotate it and show it to you how it works. Okay, let me show it again. It's gone wrong. Otherwise, so it's now. Example is this sketch. You can see this is sketch number, and whole here, if you see this whole drawing, it's not a piece of drawing, but it's a whole key plan of some layout. It's key plan. This example is JT is here. You see this JT, this C is here. This all C here. You can see this C line like this. It goes on. As you can see here, and then in this area, some road here. So it's an avenue D, and then it's pipeline coming like this, and this is refinery area here. This is only indicative. It doesn't refer to something else. This is refinery area, and this is certain plant itself is a plant, is a super plant you can say, and there are certain facilities here which draw products, byproduct from this plant and use here. This is, you can say, kind of certain plant which gives ethylene, and in that case there are various areas in gas. You can say this is a process area, is written here, process area, and this is that trains are written here, train, train, train and train. Then you can say here is entry area for those who want to buy something, and as well as you can say here are certain, as you can see this area where landscape, chiller, compound and all this is written. These are away from process area. And there are other plants as well in this. Here is a plant, there will be other plants here, and certain buildings around, and certain buildings like this around, electrical buildings, and certain warehouses. Like that, there are so many things we find exclusively different for every plant, and it's really very much, you can say, its dimension is more, even you can see here 3.38 not meters, this is kilometers. You can say this is like this is 2.47 kilometers, and here you may say how much, maybe much more than that here. So dimension not an issue here, issue size. And here we tap water from, we pump water from, here you can say C, and this pipe is GRE, sea water pipe, 2 pipes in one means pair, and it's not small, it is 7 feet or 84 inches pipe here, that is twin pipe, and this comes here. Here you can say there's a facility, this is known as facility, you can say this is seawater basin here, this is that, this is that facility. This pipe comes here, stores water here, and this water is circulated to whole train here, all area, for purpose of cooling, and then cooling water is recirculated and recirculated and recirculated like that. And there's a lagoon here, you know what lagoon is. There's a control building here, the electrical buildings here, substations and the various pipe racks. And this administrative area is called, some call offsites, some call something, so don't worry about that. Then various areas are there in the indicative plan, and it's written that trains include compressors, various equipment, vessels, compressors, boilers, GRE, and the pipelines run below ground. GRE says glass reinforced epoxy, these are epoxy based actually pipes with various processes we'll discuss in somewhere else. Other pipelines run below ground in all process areas. External connections are not indicated on the ground useless drawings. Road crossings are shown on those drawings. Seawater basin supplies water to all trains, and water is used for cooling, and water is recirculated. Some buildings are blast resistant, some are blast resilient, and some are non-blast buildings. And processing equipment housed in steel buildings, and this everywhere. Then there's a trapezoidal open ditches on all roads. The Papa just let you know what I'm talking about. You can say this is what I'm talking about. And there's so many buildings here I'm talking about. Buildings like this warehouse building, as a, you can say there's another small building, this building, there's a wall. You can say a compound here, administration of water compound. There are so many other buildings here, you can say these buildings, and there are buildings here which are blast area buildings, and electrical, as we call them. So fire station is also there, and the workshops and administration building and all that are there. So that's the difference which I'm telling you about this. So we can say that okay, fine, it's okay, I understand that. Now I put off this sketch just for information, it was, so I put it off. Let's say now we're talking of quality designs constructions, it's an important part of this, and that's very important. In this we said that this is what we're talking about. And now it is that we come back to our discussion of this buildings, RCC buildings, and I explained last time what I talk about in these buildings. Then there are so many methods here we are going to discuss. Before that, we can say we have to undergo talk on quality and talk of requirement of designs. Why designs are required? What is purpose? Designs, is it only structural design or many other classes of designs in construction? Then method statements, which is, you can say, practical backbone to achieve standards, designs, quality in construction, and how time, cost, and risks, time, costs, and risk reliability are related to that. Quality, you cannot say it is just a quality. Quality means complete quality. Quality means system of quality. It doesn't mean that test and approve something, that is quality. That's a part of quality. Approve something. You cannot say that is complete. Quality, when we say quality in whole process. When we consider project, this means whole project, from inception stage to handover or delivery stage, when project status is eliminated. You understand? When I say from initiation of project or from dream of project to delivery of completed project, at that stage we can say project does not stand. Project is completed, and when project is completed means project term goes away. Means project is finished. Now it comes to an entity or a plant or some unit, built unit, which is going to be used, which is going to be in process, and that we can say it may be called something plant if it is plant, or it is a facility. You can't call it some township, you can call it city, whatever you can call it, building. Means project is very temporary, frankly speaking. Project is very temporary, but this temporary stage contains everything. We feel happy that project is temporary, but this temporary makes everything permanent. You have to understand this point. It may be 1 year project, 10 year project, 5 year project, 3 years project, for whatever duration, depending on size of project and immense, requirement of that and availability of material and what you actually want. You may say a couple of years are required for project, but you can say many times of that project duration, it works as operational unit. Operational unit. I'm saying it works, it goes to operation. That point is very important when it goes to operation. We may take it seriously or we may not take it seriously. That's our problem. But it says, it requires that we have to be very serious about that. It's because buildings, and building doesn't mean building structure, that's everything. When we say buildings, doesn't mean it's name building. Plant is also building. Construction of road is also building. Is building here we can say as a work, build it. Not building structure. I'm not talking of structure, buildings. Building plants, building, you can say city, building sewerage line, like that. You can consider, otherwise building is building. So we have to be very analytical in that, and that's why I'm saying analysis. Analysis, I should add to that. If I add this analysis to this, it will be much better understandable. A term, if you say let's stand for that and add, you can say quality, design, say, if I at end, let us say at end, I can say analysis, let us end, analysis. analysis. I'll come to your own place. Let me just take this analysis. You can say, okay, hold on, analysis and synthesis also. You can say synthesis, just for explanation. Synthesis, analysis. Oh my God, what this analysis is? Analysis is. So I can convert it to PDF. Just a minute, please. Let me, so that you can see it. Synthesis, reliability, risk, time, cost, method statements, construction designs, quality plus, I should say, rather than quality better. Quality plus, okay. Then construction plus, I can say construction plus, and then reliability plus. Let us change terminology better. It's in the interest of everybody. Hold on, please. I'm just coming to you. Let me see if you can understand this. Let me see if I can print, and this is print. I do print. I can say okay. So let me close this file and open it again. It's better, Alright, let me see. Let's open this. It was not taking, so I open this and let us print again. So I print it again, so it's fine. Now I'll see this. So my dear friends, I'm saying is now that this is helpful for you. You can very understand that. So we got it. Quality plus designs, construction plus method statements, time, cost, reliability level. I'm saying analysis and synthesis. This is actually, you can say, this is real process. When I say analysis, synthesis, you should understand this point. It's something, it's a big process. And we should say it's a real process. Analysis, synthesis, analyze this, we can say, or synthesize this, means these are complementary terms to each other in plus and minus. Complementary in that sense, it is plus and minus. Analysis, synthesis, when we say analysis, synthesis, something which you can say, when we say problem, what does it mean? When we say there's a problem, why we say problem? Because it is to be inquired. Probe, P-R-O-B-L-E-M, problem. And when problem is there, this means you have to investigate that problem. There's some real hindrance, there's some obstruction within that problem which is not allowing to answer. It's, what it has. We have to understand problem and is to go and probe it. Generally, say probe is ongoing, we say probation period, right? We say probation period. What does it mean? Your investigation will be conducted. What efficiency you are you really suitable for this job? So we call it probe. As probation period. Here is same thing, and you have some problem. You are not clear about that problem, and that's what is. Solution is achieved, then problem goes, no, there's no problem. It's called solution. And in every designs or world, otherwise, in your life itself, analysis is very, very important for everybody. Well, problem lies in that analysis is not easy, and also that it's not very difficult if you have experience or if you have understanding, you have common sense. Everything cannot be solved according to theory, according to your education level. If you don't have common sense or general sense, or you can say sense how to live, if you don't have capacity to use your mind, and you say I can solve problem, it's a lie statement. It's complete untruth, non-truth, false. When I say I can understand this problem, problem understanding means what? When I say, okay, I got this understanding. Yes, you understand problem, because it is also not easy to understand problem. This means to understand, you have to analyze something to understand that. There is a problem, there are many, many questions in that problem. Some problem contains two questions, some problem contains one question, some problems contain many, many questions, a group of questions. And you have to streamline, you have to chart out, you have to, if not chart out, you have to really think of, means what problem exists, does it exist in that? Can I find solution? There may be 4 problems, 5 problems, and you know answer to one or to other thing. That process, to know problem in details, to have grip of that problem which you are not able to solve, it's such a strong nut. And when you solve it, means you can say solve is at end. When you understand it, understand every question of that problem, it's called analysis. Analyze. There are many, many lists in that. You have to arrive with all questions within that problem, and that alliance is called, a combination of those alliances, all alliance called analysis. If you analyze it, you shall only understand problem. That's no solution, mind it. It may be mathematical solution, it may be non-mathematical solution, it can be calculative, it can be not calculative, it can be understandable, it can be, indicative understanding. Means whatever you think and find from that, you can say, I have understood this problem. One was problem, then you understand problem. And that understand problem, to what depth do you understand, that is called degree of analysis. Okay, I got this, I can understand this, I can think about this. When you think about this problem, that's called analytical start. There may be many problems in that, there may be many questions in that, and one by one, you understand those questions. You can say, yes, I got thorough analysis of that, or I got part analysis of that, I'm waiting for more information so I can analyze further. So if you analyze thoroughly, you'll bring out all analytical questions and understand them. And when you understand questions, you have to answer. Either you do not answer, questions you understand but you don't answer, no problem. Somebody else know it. Somebody else knows it, so you have to refer it to that person, or you have to consult that person, or you yourself know those answers. That is what we say. When we those answers and reconnect them, one was questions, 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 questions. You pull out those questions, question number 1 in that, question number 2 in that, goes like that. And when you answer the answer number 1, answer number 2, answer like that, answers are summed up again, and that's called synthesis. Analytical based synthesis, you can say, or synthesis based on analysis. You understand this point, this is very integral part of engineering. In engineering and in life, these are very important. Problem only lies in that we remain in panic when there is problem. When there's a certain problem in your life, you are nervous, you become nervous, because in that state of being nervous, your capacity of during that stage of being nervous, capacity of your thinking is actually eliminated. Capacity of your thinking goes away, and you cannot move on that problem. And that stage is, you can say, momentarily. That stage momentarily, for 5 minutes, for half an hour, for an hour, and we calmly, if you sit calmly, that vibration of getting nervous shall go away. Analysis means use of mind, to be very frank. Many times it has been explained. Ability, lie, ability, rely. Forget rely. I say ability. ABILITY plus. You this material is able, you can say, if not you, and you can say if that is useful, if your ability is useful for performance, means it's useful for being safe first itself and then keeping others safe, and also it can serve as well as it can live long. You got my point. And many other factors like risks and risk cover, like cost controls, time controls, and construction able based on designability and quality. If we relate them, these terms, and reliability plus. In engineering, reliability is important, very important, significantly important. As well as in life, it is important. There is no way that you can run away from reliability. Reliability is understandable. We have to understand what is reliability. In engineering is equation, you can say reliability equal to safety plus service plus durability. You know safety, whatever product you buy, and you yourself are a product, for example. You should be safe and your work should be safe. Whatever you do is safe. And whatever product we buy, it should be safe. It should be having safe quality. It should perform, that's called service. And also, it should not only perform, it should perform for a set duration, for design duration. Means it may be more, it's okay. But for a particular period, say 5 years it is designed for, 10 years it is designed for, it's called durability. With same quality, with same performance, with same reliability, it should give you. Of course, for when you use it many times, you can say its tenure of life, it goes on diminishing gradually. But there are ways to retrofit that. Why? That durability, we call it, means 5 years, 10 years, 20 years, whatever. It shall serve to same degree as was designed for or intended for. That's reliability, and it applies to your life as well. Are you reliable? Is your family member reliable? Is your national leader reliable? Is your work reliable? Is your design reliable? Is your construction reliable? Or can you take up this factor, keeping abreast inclusion of this risk, that you are going to work, you are going to do this. Also, simultaneously, you keep in mind that such risk exists. Those factors which cover under the risks exist and you have to tackle them. So that is called calculated risk. You know, there will be this risk in this job. So in that case, you can say that is risk which you know. It's not unexpected. It's not hazard. You got my point. When you know that this you are going to do, this shall pose this problem, which is part of analysis. And that problem you can tackle. So there is chance of that risk to happen, but there is a solution for you if that risk comes in. So that's not hazard, because you knew it. It could happen. Also, hazard means when you do not know something would happen, and that's called hazard. You may say hazard analysis. So that was calculated risk-based analysis. So this is hazard analysis, where you may not expect something, but it can happen. And in this case of, you can say, calculated analysis, calculated risk, you can say, oh, this is going to happen. So I have to take precautionary measure. I have to take, before doing that item, some measures which would prevent that risk or which will give you least damage. That's all. Like you can say, I know it's expected to rain today. I have umbrella I take with me. If it rains, I will use it. If no rain, no problem. Maybe it's for sun. So you have umbrella. That is calculated risk. But you don't care for that. You don't know what's going to happen and thunderstorm is on way. That's hazard. There's a difference. Well, no problem. I'm not teaching like that, but I'm just giving references. Now says time. Time is only wealth you have. Time is only wealth we have that doesn't stay for you. You may be rich, you may be poor, you may be powerful, you may be leader of whole world, you may be king, but time is not your friend. Time is your friend only if you value it. If you don't value it, it kicks you out. Get lost. Use this power of time. Time is not your slave. Time is not your servant. Time does not care whoever you are. It works, it's very punctual, it's regular. It doesn't stay for anybody. It doesn't wait for anybody. So time is a power, you can say. If you use this power, time is yours. If you don't use this power, it's not yours. This means you have to submit to time. Time is not going to submit to you. And submission to time means you are smart. If you can understand time, really you are intelligent, you are smart, you are reliable, because you are able to utilize time. Only free money, only free material available in the world is time, resource, source. Time of your life and time, both are linked. You waste it, you can't recover it. It's not money, you waste it and you can recover it. Time is not money. And you can also say time is money. Both. Means it's not materialistic money, but it can bring money for you. And money doesn't mean money only. Money means power. Money means your progress. Money means augmentation in your life. You thrive further. So time is that kind of source. I should say source. It doesn't stop. It doesn't wait for you. You have to wait for this. You have to do for this. And even don't wait for it. You keep ready. And I say, don't wait for this. Intelligent people, hardworking people, dedicated people, they do not wait for time. They keep themselves done, They keep ready for whatever happens, even though they don't know this work doesn't relate to my activities now, but still I'm doing because I have time. That person is all because here time forces him to do something which is going to be used in future. And this is how this happens. Today I do something, it doesn't mean today I use it. Maybe it's pre-planned. So in actual sense, you can say it is a preparatory maybe. If time you use like this, you think of something and do, okay, I do it and maybe it's used in future. It's preparatory resource. You may not prepare it in future, but now you prepare it. You are getting automatically prepared, and this if you make a habit, pre-think means something is going to happen and you are ready, you are earning your resources, for future. And this is what I say, cost related. Yes, today you invest your time, if you have time, and this is another cost. Maybe when the reality comes to use that, it will be very expensive, but already you have done it, so it's good for you. You will have many reviews by that time. So it can cover many risks, if you are ready for that. It can cover many unknown risks. 11th hour thinking and, in a seriously considered way thinking, both are different. 11th hour thinking is already erroneous. But if you think like that, I keep prepared, I don't know what, I have done this and I keep myself, this is in reserve. That's where engineering lies in. Engineering is to think, I did not add that, but thinking, of course, is real engineering. So quality plus, when I say quality plus, then designs, construction, method statements, time, cost, scalability, analysis, synthesis. You can say that analysis and synthesis also thinking. Both. Think. I didn't write that, but it can be thinking. And thinking is, I should say, if I add this to the beginning as well, it will work. So quality of thinking, you know, quality plus design. So whatever kind of design, not structural design alone. These terminologies I'm just writing, though these are very simple words, but these are exclusively dominating words. Our quality system, which I'm talking of. Quality system doesn't mean that we have to be slaves of those systems which are given to us like ISO or like Sigma or like, these are man, all we devise this. So you can also devise your own system. Who bothers? You consider yourself an institution. If you are having capability as a professional or otherwise, you can devise your own system. I always have my aim, I always have my approach. Either I be a part of system or I make my own system. This is my approach. You got my point? If I say part of system, what does it mean? It means there's a building, some plants. I build my plant. I'm a plant. What's wrong with that? I'm a plant. I say, okay, it's my system. Or I am so regular, I am so abiding person that I'll follow your system because currently I don't have a system for this. So I sincerely follow your system. No harm. No harm. And that's called discipline. We call law-abiding person, system-abiding person. The disciplined person, that person understands and follows and complies with. Until or once you are in a system of other one prepared by someone else and you immerse yourself in the system, you learn that system and you can amend that system because you learned that. You immerse yourself. Just follow up is not enough. Follow analytically. Follow thinking wise, one by one. You can think of how this is working for this system, this content is working for system. If I replace this content, it can be a better way or something else can happen. That point is really appreciative. But when I get the command of the system, I can understand everything of the system person concept. I'll certainly find defects in the system, snags in the system. That's my duty to find as well. Because after all, we are not slaves of everything. We are slaves of time. So that system in which I have entered, I have assimilated, I have gripped in, I can either reform that system or I can say, okay, gradually we enter into other system which will be further better than that, and following existing system we can convert to new system. That is what we can say quality is. Quality doesn't mean this is stagnant. Quality keeps on moving like river moves. It doesn't stop. When something is stopped, water is stopped, it gets septic, it gets stagnant, mosquitoes breed in, and that's the problem. When we talk of engineering, means engineering is actually speaking basics of thinking. One is thinking, one is basics of thinking. Engineering is thinking. And in fact, whole life is engineering. Whole life, everybody's life is engineering. I'm not talking of civil engineering or some other engineering, I'm talking of engineering. Means whatever you do in your life, you have to think. You have to think superficially, you have to think in details, elaborately. And you have to go to whatever extent of thinking. That's very important point. When you start thinking, that's your quality. That is your design. You can say, oh, he plotted this, he designed this, and he did this crime. Or he designed this structure, he designed this factory, he designed this business, he designed this and designed that. We say that, right? Designing clothes, designing this. Whatever you do using your mind in some different way, that's called design. Sign and design. When you sign something and spelling design before that stage. When we talk of this, everything is construction. Construction of paper, construction of design, construction of drawing, construction of building, construction of something, construction of your character, construction of something else. Means when you say where a structure is created, some structure is created, that is construction. I'm not talking of building construction. I'm talking of construction of imagination. When a child makes a drawing, you can say that person, a child constructs drawing, or we construct this figure, we construct this and construct that. It's very universal word. It can be used everywhere. And what is method of that construction, that we have to understand. Method of that construction, if that method is formalized, this method is written or spoken or recorded, and it works successfully, that's called method, construction method, you can say. Method statements means written statement or recorded statements or spoken statements. What are kind of statements which you can say makes very good tool in engineering for expression of how shall we do this work or activity, a whole project or disciplinary works. That's method statements we are very much concerned with. Spines not that easy, and everything works on reliability of time, reliability of cost, reliability of risk, you can say, and quality, of course, is the. So what many points we got in C, you can say we have quality understanding, we have design understanding, we have construction understanding, statements understanding, time, cost, stability understanding, analysis and synthesis understanding. These are very spatial terminological, very simple words which you have to understand before attempting to do, you can say in a way, intellectual way something. So we can start with analysis and then we can synthesis structure, structure is synthesized into construction, through construction is some useful unit. But that's through analysis, everywhere analysis is done. Reliability happens of all factors, of considered knowledge areas as considered management knowledge areas, and that's what we say. The very important point is quality, design, construction, statement, methods, time, cost, stability, analytic, and synthesis. These terminologies are your own. You can understand them. So we can say if you go to quality world, we should have certain statements written for some activities, for something. Here I'm talking in general. We talked yesterday about the statement of concrete RCC walls of some building that we talked of, and we understood that well. No need to read all that, but in that some statements were detailed in, and we talked on that. Now, if we go next one, you can say mains, there's substation, main or no main. I'm not going to that one. We have to understand what substation, that this point is substation. Station and substation, of course, this is not main station, power station, and substation. There are various substations everywhere. And that in a sketch, I say electrical building, substations, electrical building, power station, then substation, then further, maybe many grades of substation, 66, 11, or 130 something. It depends on kV. So here I'm not concerned with about electrical designation of that, but it is construction of main substation. I can say what is main substation. That's the point. Now in this case, index is same. You can say scope, reference, documents, definition, responsibility, safety methods, equipment, attachment, etc. These are statement is to define sequence. Purpose of this method statement is when I say methodology for construction of main substation or whatever substation it is. Now, only RCC works are covered in this statement, number one, which include elements such as foundations, grade of floor slab, floor beams, stub columns, grade of floor slabs, columns, walls, and roof suspended slabs. Only RCC works or RCC elements are covered in this statement, which include elements such as foundation, grade of floor beams, stub columns, grade of floor slabs, columns, walls, and roof suspended slabs. Documents are specifications which are available and recorded. Then we can say MS1 for general definitions. MS1, okay, fine. General definitions, there we'll see what are those. Then we can say MS1, I think it was here. If see MS1 it was or what? It was MS1. Okay, this is MS1, which is general definitions, and that are here. We can say there's all definitions like designations, titles, responsibilities, then safety, all these already covered in that. So we can say these are covered here. You just think, you refresh yourself, general definitions. Now, responsibilities, if you refer to method statement 1 as we says, yeah, general responsibilities, and then titles, and then we get safety. Now, its method sketch 62, indicative only. I'll see what's that, no problem. This method statement details only structural concrete works. Structural concrete works. And also finishes, steel sheet roofs, ladders, access platform, internal and external insulation, galvanized steel mesh are not included in this method statements. Main substation structures to be constructed in the following stages. We'll see that. Let's see what 62, if I can find that, what's that one, 62. If I can find out, I'll see that. 62 is openable or not, that's my C, 61B, 61A, 61C, 62. I think I have to go 20, building plan, let me see, 62, I can try. Let me see what's the R62. That's also important here to see what 62, let me see. So this is method statements, books. Sixty-two. Okay, I got it. 62. Okay. It's a good one. Really. Okay, I'll see this. What actually it is? Let's see. Okay, this is one. This is sketch of a substation. You can see first you review this sketch. It's very important. You see this length is about 100 meters and 10 meters this way. So width is 1/10 of length, or you can say length and the breadth. It's a plan, and also you may say this continues. You can say here same with some room here, and I think it's same. Sketch 22, electrical substation building, indicative only. That's point here, indicative only, and it says that building height 8 meters, cable trench RCC, with checkered covered precast covers. This is cable trench here, you can see in this case. This is cable trench, maybe, yeah. You can say that. What says block walls in non-blast areas. RCC wall around HV room when located in blast area. So, transformer foundation RCC and transformer firewalls RCC. It is said there is a ramp here. If you enter here in the substation, you can see here are transformers. You can see these are transformer here. All these squares indicate these transformers, and these are firewalls. You can see here RCC walls. This transformer firewalls foundation is RCC. This is columns, RCC walls, etc. This is switch gear room. You can see here inside. And this is staff room, engineer room, and control room, you can call it 15 by 15 meters. This is the indicative electrical substation building, and this is cable cellar here. This is ground here. This is cable cellar. This basement is block ground. This is situation, and this is ground. You can say HP switch gear room is here. HQs, and this is cable cellar. Cables are in basement. Cutouts, openings to be provided in cellar cover slab. Cutouts or openings to be provided in cellar cover slab requires the ground floor. Same thing. Then down ladders are here. If you use, because you have to go to basements, in slab is a cutting down like that. This is a ramp from existing ground to plinth of this, grade of this. And there are fence and gate at all transfer compounds here. Fence and gates here all. This is general specification on the sketch. This height is 8 meters, a reasonable one because it installs switch gears and transformers. You have to understand this point. So we can say what else say that in this situation. But it represents here that the sketch indicative only. This method statement details only structural concrete. So let's say stage 1. What is stage 1? Earthworks. There are how many stages? 8 stages defined here. Here's 1, 2, 3, 4, 5, 6, 7, 8. And it says in earthwork, in stage 1 we cover. I mean, it's just it's for method statement's sake. It's not that we have to do only that. It's just for how we consider into our explanation, what's basis of our understanding. That's point here. Earthworks, we say blinding, waterproofing, scred protection up to defined elevation. That's number 1. We'll explain this. Number 2 is footing pad construction. Footing pad construction, including kicker up to 100 mm above top of footing. Then number 3 is stage number 3, step columns, walls, including anchor bolts for galvanized screen mesh up to underside of floor, slab, ground beam, defined elevation. Number 4, ground slab of HVAC room. Ground slab of HVAC room, including anchor bolts for ladder, access platform, top of concrete. Then stage 5 is floor slab for main building, top of concrete. S6, stage 6. Stage 6 is wall construction. Wall construction up to bottom of roof slab, roof beam elevation. 7 is roof slab construction, including kicker for parapet wall. And stage 8 is parapet wall construction. This is all in elementary stages. Then we go to transformer base and foundation, which are again, which we talked of here. If you just remember, this is transformer base, like here. This is what we're talking of. And then we can say transformer base, and foundations are to be constructed in following sequence. Stage 1 to 7, 8 I think. Okay, 7 stages. Earthwork, blinding, waterproofing, skid productions, and footing pads construction, kicker, about top of footing, including water stop, water bar, for transformer bay, partition, wall and boundary, wall footings, transformer bay partition walls, full height 10 meter, including cast and anchor plates for roof truss, and transformer bay for boundary wall, including cast and sleeves for fence post. Then transformer foundation bases, including bases for sump and well pit, and gravel fill between foundation and walls, and steel roof truss and roof. This is simple line statement of this, and this is, I think, a long statement, so no problem. We'll go one by one because it's better to understand something rather than running for sake of running, which doesn't do anything. So we have to be very much practical here. So these are just, you can say, small title statements. It says clearly means main subsystem structure will be constructed in following stages. And these 2 stages, stage 8 and 7, contents of this. Now what it says, setting out then. Let's say grids. Understand what it says about grids now. Maybe it's not given here in the sketch. One maybe 1 to this here, or something like maybe something missing. 1 to 13 A to D, for example, it is 1 to 13. Okay, it's not given, but we can think of 1, 2, 3, 4, 5, 6, 7, 8. Like say, maybe some grids are shown on other drawing, which is not shown here. A, B, C, and AB, like that. A, B. It can be C here and D here, and there can be grids. What says there can be grids. Means it's written A through D shall be offset 3m. Now, grid line 1 to 13, this point shall be marked by nail. It says we have to set up this on site, and that depends on your surveying and drawing. Point shall be marked by a nail driven on top of wooden bags driven into ground and set in concrete. Now, let's say stage 1, one by one we stay stage 1. That's here, stage 1, that was, stage 1 was here itself. That is earthwork blinding, etc. Let's see how it works. Stage 1, setting our building shall be done with the grids. Setting out the building shall be done with grids formed around for reference clearly, fixing benchmarks for leveling purpose. So let's see, setting out the building shall be done with grids formed around for reference clearly. So you can say, we can just, we close this first of all. Okay. So this point here, we have to understand this point. We have to set out building. We have to do it with grids formed around. Grids means temporary grids formed around for reference clearly, and those grids shall be there till building construction goes on. Then we can say fixing benchmarks for labeling purpose. So number 1 is grid fixing, A, B, C, D, 1, 2, 3, whatever it is, and whatever spacing is given. We have to say fixing benchmarks for labeling purpose. We have to fix benchmarks, means GPS system has to be brought to site for coordinates as well as for labels. Horizontal controls, vertical controls. When it's a control of coordinates, northing, southing, easting, westing, we call it that this is grid control. And when we make a horizontal control from available GPS system, we shift it to our site, and whatever system says in JPC to our grids or control corner, we fix that. That's horizontal control, and you can say, some people call it latitude, but it doesn't matter, whatever it is, we have to bring coordinates to your site, actual coordinates mentioned, and then you can say fixing benchmarks, the vertical control, level controls. You can say you have to fix some level there on site benchmark. You may call it 0 for your site purpose. It's not 0 in fact, but for your site work, you can say it is 0, and when you take reading on that, that's called height of instrument plus 0. Whatever reading you get on your leveling staff, you can say this 0 plus this reading is called height of instrument, and then you can deduct other points from there. After height of instrument is obtained, you can say, you can take other levels, wherever you can say reduced level. Here reduced level was 0, reduced level plus reading of staff is called height of instrument. You want to establish other levels or check other levels, you can check them, you can establish them. So what the height of instrument you get, and you do that reading at whatever point, that's called reduced level of that point, RL we call them, reduced levels. It's not exact levels of GPS, but the referred level, you can say it's difficult to always consider GPS level, so let us say it's only reduced level, RL we call it, which in relation to benchmark we fix work. So fixing benchmarks for leveling purposes. Now, inspections regarding setting out to be conducted for approval and submission for records. So nowadays practice is better you control it through third-party system, which is licensed one or controller of this survey. And that's better, I think, but doesn't matter, even inspection is required. So inspections regarding setting out to be conducted for approval and submission for records. Then you can say excavate whole area. Now excavation starts, this is just survey work. Survey work is done. Of course, excavation you have to do. First activity, excavation whole area of foundation, excavate whole area to foundation. Or you can say whole area to foundation level or formation level. This is called formation level, where you have to start with blinding concrete and then work upon say excavate whole area to formation level with continuous monitoring excavation levels to avoid over excavation in whatever way it could be. Is very important point for everybody. When you do machine excavation, not the manual excavation. Nowadays manual excavation is not generally done, but machine excavation is done for everything. We use JVC or some excavator, and generally bucket is its teeth are so strong of this bucket and volume that over excavation chances do exist. So it's better not to You leave last layer, very small layer, say 10 centimeter, 20 centimeter, leave around, which can be covered later on. Otherwise, if you excavate more, it becomes a problem. Over excavation is not accepted, or you have to start foundation from there itself, or you fill it with concrete, but people want to compact that. So it's very important point to keep in mind while doing excavation. You have to continuously monitor that excavation level, so that over excavation is not done. Under excavation is not a big issue, it can be addressed then later on. So excavate whole area to formation level with continuous monitoring excavation levels to avoid over excavation in whatever way it could be. Then further excavate for transformer bay. Now we are starting transformer bay, for example. Further excavate for transformer bay partition, wall foundations to required elevation during elevations monitored. Further excavate for transformer bay partition, wall foundation to required elevations duly monitored. So means first we did excavation levels, then we reached now we reached found formation level or partition walls, whatever it was, wherever it is. And further excavate for transformer bay partition wall, foundations to required levels, required elevations, monitor. Elevation is same thing as level. It's level if you use, okay, elevation also same thing. Create access ramp at either short ends to allow heavy equipment to get in and get out regularly. It's very site control section. Then using grader and 12-ton capacity roller. Using grader and 12-ton capacity roller. At formation we have reached scarify and compact to required elevation plus minus 20 mm. Well, it is practically what you do. Level difference is always there. So you have to scarify, you know what is scarifying, just giving some cuts in that, in compact art, so that it's well suited, dense one. And of course you take test of that, that's called conduct FDD, that's called field dry density, test for degree of compaction and get approved. Of course, approved is a part of the process, it's quality control process. Then reset out grid lines 1 to 13 and A to D. Means you have to check them again and again using steel pins to be located 2 meters away from outer edge of concrete faces. So there's a margin with excavation or construction work will not come in the way, will not break them. This established temporary points of survey, this 1 to 13 A to D. Now, mark grid lines with chalk powder all over correctly. Mark grid lines with chalk powder all over correctly. Like that. Now, use timber reapers to construct edge, form and place blinding concrete to elevations whatever is given. 200 mm wider than required, right? Use timber reapers to construct edge forms and place blinding concrete to elevation 98.5, 200 mm wider than required. Who's this bloody fool? I don't understand these people. Every day they do like this nonsense. You can see. Oh my God, what to do? All right, just disturbing. Now, what I was doing, sorry for somebody disturbed me, and I was, I don't know what to say. I have no comments on that, beyond my control. Now, reset out grid lines. This is that 1 to 13 E to D, using steel pins to be located 2 meter away at out edge of concrete fence. Mark grid lines with chalk powder. Alright, use timber reapers to construct edge forms. That is for blinding. Well, reapers you may call them, timber you may call them. You have to put some, it's a maximum 75 mm, 100 mm, 50 in between this range. So, but it should be straight better on that approved approved layer of soil. You have to do blinding, concrete. Blinding means, meaning of blinding, I think. Whatever elevation is there, and you have to, wherever a foundation has to come, to keep some offset, let us say 200 mm, wider than required, so 100 mm on this end and 100 mm on that end, wider than that. Then you have to cure this concrete according to specifications, requirements, at least for 24 to 72 hours, depending on further activities, progress. And moreover, this concrete cannot be ignored. We call it lean concrete in our country, but I don't accept that. It's the concrete part. It should be good one because it has to receive concrete protection layer. That's called waterproofing. Generally, people call it waterproofing, and it's called actually on this we lay concrete. On this concrete we lay concrete protection layer, or we call waterproofing layer. I have explained this already many times. So curing concrete according to specifications, requirements, at least 3 days for, can say, depending on further activities on progress. Then it apply waterproofing membrane in sections 1 day. That's what I showed you. I told you prior to fixing formwork for base pads. Now test laid membrane, which you have laid this membrane. You have to test laid membrane if required within specification for conducting vacuum test. This vacuum test. Vacuum test is conducted to make sure that this membrane is fixed on beam. It doesn't come out. It's very ordinary test, vacuum test. So it's test laid membrane. Test laid membrane means already we have laid it. We have to test that membrane using vacuum test. Apply membrane protection screed over all areas if so required, and if not, do not protect heavy duty membrane. If it's light duty, now it is heavy duty is used. If light duty, you have to provide screed. It depends on your design. And if it's very heavy duty, I think no need of screed, just continue, because the work of steel fixing or cover blocks won't damage it. It depends on what sort of start. So it's number one, I can say, in this case. One, we'll review it after going through this. Stage 1, we'll review it. Let's go to stage 2, or the states that now place fabricated. Place, you can say, let me just keep it 190 so it's better for you. Let's say place fabricated footing, 175, 180 I think, 180 I think. Place 175, I think. It's not covering it. So place stage 2, place fabricated footings, rebar. Says place fabricated footing, rebar, cages, already it's done, yard, well protected. Place fabricated footings, rebar, cages directly over locations, duly supported by concrete spacers. Spacer, what's concrete spacers? Concrete cover, generally we call it concrete spacers. This is. Starter bars may also be placed, starter bars must be placed on locations. Writing is started, that's error. So starter bars, first bars can say may be located, may be placed on locations and tied up with rings or stirrups at indicated spacing. Place formworks, formwork or shuttering. Place formwork directly on waterproofing membrane, protection screed, fabricated formwork shall be placed over marked settings of footings. We have to mark lines of footings, and on that lines you will have to place formwork, fabricated formwork. All sides shall be supported by horizontal battens, steel jacks as well as inclined scantlings. We have shown all this in formwork. Now that file will show sometime else because that's on another system, not here. Formwork for kicker shall also be prepared. Kicker means sometimes we use, sometimes we do that, but if you want to use, there's no harm. Formwork for kicker shall also be prepared over completed work. Around columns, walls, place, and place steel reinforcement with starter bars for column or walls. Place timber reapers on both faces of formwork for construction joint at location indicated on sketch number 1. Let us see what is that sketch number 1. Let me go to sketch number 1 and see what it says. Hold on please. Sketch number 1, maybe some important sketch. I don't exactly remember because it was done long back. Many years back, in fact, it was done, not long back. So let me see sketch number 1, what it says. Okay. This is. I think this is excavation trench. Sketch number 1. This is trench ladder. Let me show you when I open it. It doesn't matter how it looks, This is a general sketch actually. It's not that one. This is, I think, a general sketch. Method student sketch 1, safety post and all that. We have to provide this trench, and this is ladder here. Just pick how it is. Trench execution safety it is. It's not otherwise. Okay, fine. And we can say so. I say this. Sketch from this one, okay. Now we go to. Now care will be taken to ensure that contraction joint in west wall would be hidden behind GRC fascia. Care to be taken to ensure that water bars are placed at right position. Water bars are placed at right position on edge of pad concrete for transformer bay, partition wall, and east wall. Okay. Water bars have to provide, if it is in designs it's given, to provide that bars placed at right position on edge of pad concrete. That is half for transformer bay, partition walls, and east walls. Cathodic protection shall be installed to meet defined requirement such as critical or non-critical. I explained to you cathodic protection many times. You know what is cathodic protection. Cathodic protection means anode is to be placed or boss is to be placed in ordinary foundations which are not critical. Boss is placed at one point, and then there is a wire which is connected to your circuit, and in critical this is C-clamps and wires all over steel provision foundations, one bar by bar, and all rebars are connected together, which is tested by voltage continuity. So cathodic protection shall be installed to meet defined requirement such as critical or non-critical. Then isolated footing basis shall be cast on in line to approve concrete pour procedures. A basis for wall footings, wall foundation shall be cast per sequence shown in attached sketch 2. For post-pour curing application shall follow. So these are ordinary. When now go to stage 3. Those sketches are not a sketch actually. This was method statement sketches which are not shown here. Now stage 3 is what to do. Actually, this system is very much, can say, you can say, we are talking about these foundations and all these foundations here, walls and foundations. We are talking about these. And for this method statement, some sketches might have been prepared for everything, which is not shown here. This is not this sketch number, actually, don't be confused with that. So what we are saying is that here. So now stage 3, then 4, 5, 6, 7, 8. How many stages are there? This is of course critical. And as you see, sketch 1, 2, 3, 1, 4, 2, 3 are written here, showing locations of construction joint, showing construction joints for floor slab, showing construction joints for roof, showing concrete pouring sequence. So it's okay, fine. That's not with me now. I can't show that one. So let's go to it's that one. So post-war curing application shall follow. Here's stage 3. It's more than an hour ahead. I have to walk a little. It's a problem otherwise for me. No, 1 hour more than 1 hour is so okay, no problem. I'll read a little and go for just 5 minutes walk to stretch my legs. That's required for me. Now says chip out all previous chippings. Well, hack out all previous chippings or debris from portion of columns, construction joint. Construction joint is a very important part in engineering, which people don't understand here in technical way. People don't care for construction joint. I don't know why. Doing well, that's but engineers should be engineers should know it. Means first construction joint. It's very important part of this. I have to explain that one before going further. Meanwhile, I have to just for 5 minutes. You can read this. Meanwhile, I can say it's better if you read this. I'll just pull down so that you can read more and more. This stays, that stays. I'll come back. Hold on, please. Sorry for 5 minutes. 5 minutes, and be back. It's not big problem for people. Just read carefully. We'll discuss this. Sorry, gentlemen. It happened again. Little late. I still done. I hope you have gone through what I thought you have gone through. So, let's say stage 3, chip out all previous. Chip out all previous debris from portion called construction. I was talking about construction joint. What is construction joint? We have to understand that before going further. It's for interests of everybody, engineer and non-engineer. Even sometimes construction joint is not clear to everyone. In fact, construction joint is a mechanism, to be very frank. Construction joint is not my way or your way. Sometimes it is designed accordingly. Sometimes it is given on drawings, structural drawings, and sometimes it's not given. It is emergency requirement, construction joint. So it has both properties. It's routine, given on drawing, as well as it is emergent requirement. When it is given on drawing, that indicates that whole concrete cannot be done in one go because of size and thickness of member, and we have to provide some gap, or we have to do something, or there's some technical requirement. So new, we can say immediate old and immediate new construction are connected together, or there is some failure of batching plant or failure of some machine, and you have to stop concrete due to that reason, and there's no other way out. You can't arrange to continue, which is called emergency case, in which case some stop ends, we call them stop ends, kind of what's half vertical, then some horizontal, and then some vertical, again half vertical. That shape, vertical line, half vertical line, half when I say thickness of that member, where we want to make construction joints. If there are beams, which is a little away from beam, you can say 1/3 or 1/4 of span. They are whatever section of slab is 1500, 150 mm, 200 mm, 300 mm, whatever it is. In that we make half vertical from top of concrete to some, you can say half horizontal, or 10 centimeter, 15 centimeter, then again half vertical. That setting is prepared in advance, or immediately it's prepared, that stop end, and put it in that section. It's very tedious, but it is done. So that when you stop concrete there, it becomes professional concrete, defined concrete, and that joint is at that time, we call it stop end, and we concrete up to that, duly vibrated, nothing on one side and concrete on other side. That's called construction joint. And there's a limitation that once you do that construction joint, you cannot concrete immediately, and you cannot concrete without further approval. And that construction joint, once that stop and shutters are removed, it has a part as usual. And when time lapses between two concretes, definition maybe 24 hours, 40 hours, depending on specifications and weather conditions. So when you want to connect this construction joint with new concrete, stage comes and we have to prepare this joint first. We cannot simply concrete, we have to scabble new concrete, where surfaces of new concrete and old concrete butts, the surfaces butt with each other, what half vertical, then horizontal, then half vertical thickness. These actually are scabbled. These are scabbled. Scabbled means hacked. Hacked means you have to remove water cement from there and expose aggregates fully. Of course, the steel is there. It doesn't matter. Steel you have to clean. You have to clean everything. Whatever steel is there, you have to remove all cement. spots from the air. You have to remove all loose particles from those seal bars, clean everything completely and square. You may be completely, even if there is this rusted, you have to clean it. You have to sandblast if required. Means what? Now you have to remove concrete slatings to expose aggregates, and then you have to clean steel completely. And then in concrete, you have to start from there, reach the ovens. Slurry, cement slurry is provided, and as usual, process of concrete, you put new concrete evaporated, and this becomes construction joint. So that's where construction joint is. It's not only slab, it can be in columns as well. In columns, when you stop concrete somewhere, and next time you have to do slab or other part of column, vertical part, and you have to scaffold that completely, expose aggregates, clean all steel. That's what it's generally when you do slab, beam and column junction along with monolithic slab, it's called construction joint. Construction, or sometimes call it very small piece, vertical piece of column. In that column is called neck column. This is generally coupled, so it doesn't matter neck column. That has to be prepared from capacity of construction joint. And that construction joint is I'm talking of. It says chip out all previous chippings, debris from portion of columns, construction joint. Don't go to English as written, means hackle, you can say scabble out or hack out all previous debris from portion of columns, construction joint. Ensure setting out locations and lines prior to commencing stub column works. Stub columns, you know very well what is stub column. This column is generally defined as a starter column part, means from footing it starts and goes to plinth level or ground level. That portion of small column, hardly 1 meter I think, or maybe 1.5 maximum. That's called stub column with same section as upper one, and maybe sometimes increased section also, because cover of concrete in foundation columns is more than cover of concrete in upper part of columns. That's a from level. So it depends. It depends on specifications how design says, but just that's not point here. Ensure setting out locations and lines prior to commencing stub column works. And place remaining reinforcement for stub columns and walls. Stub columns or stub walls, you also can say, up to grade of floor level. And then place formwork for stub columns and walls up to grade floor level. Stub columns, small, of course, vertical height small, we have place formwork once the steel is approved. You can say place formwork for stub columns and walls up to grade floor level. And vertical construction joint shall be located same points as indicated on it as okay, fine. Vertical construction joint we're taught of. This doesn't matter vertical for column of a wall. Now distance from corner shall not exceed 4.5 meter, and distance between intermediate ones should not exceed 6 meters. That is when it depends on what is your drawing. So that is reference to drawing. You have to see what your drawing says or what you have decided. Don't worry about this is written here. I'm just giving you tentative explanations. Horizontal construction joints shall be made at locations shown in drawing, described in this manner. Okay. QC inspection, quality control inspection shall be conducted in conduct of all prepared columns for release of pouring permission. Cast stub columns and walls up to underside of floor slab. Now, setting out for floor beams and grade beams. Setting out for floor beams and grade beams. Floor beams or grade beams shall be laid in line to details indicated. Means you have your own drawing, you can do accordingly, and after setting out is done, then inspection for approval, for records and for authority. Then you have to provide reinforcement for these beams and floor slab. Then we have to do formwork for these beams and floor slab, including 100 thick kicker forming walls. Yes, if you opt for kicker, it's up to you. Better you do it, no problem, there's no harm. Construction joints for floor slabs shall be followed according to given sketch. Now, place steel channels and box outs for opening in floor slabs. Means if it is designed in various, there will be many box outs or block outs, you can say, in switch gear control panels. Control panels, there will be many boxes out or channels. Plate steel according to your description designs, because this is industrial building or because it is electrical building in industrial projects. So place steel channels and box outs for opening in floor slabs for switch gear control panels. You know what I mean, switch gear, don't be confused. I'll just show you sketch which I'm talking of, and this is where, this portion is here. All switch gear room, high voltage switch gear room, this is. And they have to take care of this very plainly, because I'm trying to show you sketch again and again. That's the only reason, and you can say that. So install formwork for floor beams and box outs of that. Then penetration sleeves or ducts. Says place steel channels and box outs for openings in floor slab for switchgear control panels. Penetration sleeves ducts shall be boxed out for cables and utility services. Penetration sleeves, plastic sleeves probably, or ducts could be boxed out for cables and utility services. Inspection to be conducted for approval of grade of floor slab. Where's authority to inspect that? If your authority, you inspect that. Cast floor slab. Cast means pour floor slab in alternate panels. Not directly, you just make panels, floor slab in alternate panels with due regard to following, and we are talking of panels, approved procedures. Construction joints shall be located within middle third point of slab and beams as shown sketch. So it's done. Well, it's now comes next stage, the setting out of walls. Setting out for walls. Which we were talking of, this is now construction joints, cast floor slab in alternate panels. Of course, this is there. You're just doing a lower level. So it's not suspended slab, not at all. So floor slab is clearly given. So it's floor slab alternate panels, because long one. Come on, that's the construction joint shall be located within middle third point of slabs and beams. Then setting out for walls shall be ensured prior to commencing wall works. Setting out for walls to be ensured prior to commencing wall works. Then scaffolding arrangements shall be prepared for access and safe working on platforms. Of course, temporary work, the scaffolding arrangements you have to do, which is a very important part. Scaffolding arrangements shall be prepared for access and safe working on platforms. Then say steel reinforcement shall be fabricated and installed according to requirement. Steel reinforcement shall be fabricated and installed. Inspection shall be conducted for approval of steel reinforcement. External formwork for vertical walls shall be placed in position, aligned and supported. Now, box outs for bus duct penetration. Box out for bus duct penetration. Rebates for personnel and equipment. Bus duct, box out for bus duct penetration. Rebates for personnel and equipment. Blast door frames, air conditioner openings and other shall be installed correctly. These are all, you can say services required. These services required here. This is bus duct penetration. Rebates for personnel and equipment. Then personnel means staff and equipment means machines. Blast door frames, air conditioner openings and other shall be installed correctly. cast in items such as anchor plates for roof truss shall be fixed in position. Timber reapers for contraction joint shall be fixed to outer formwork face. Inner formwork not exceeding 6 meter length shall then be placed after inspection approval of reinforcing bars up to bottom of roof slab level. Design calculations included as a test based on hydraulic pressure caused by fresh concrete. We know design calculations of fluid mechanics basis, and we have to do that design calculations included as a test. Alright, this is only indicative, don't worry about that. I have not done that. I have done design calculations elsewhere as a part of. Now, formwork design is similar to ones used at seawater surfaces, so we did that before. Rate of pour shall not exceed 2 meters vertical height. Rate of pour shall not exceed 2 meter vertical height per hour. As no concrete layer shall be laid exceeding 450 mm. You see 2 meter vertical per hour, so each layer is 450 mm. One time allowing interlocking of vibrator nozzle into lower concrete layer. Wall section shall be cast in layers after pouring approval is obtained. Layers means 450 maximum. And one time you can say 4 layers, not more than that, because you have to see vertical height. You can't pour one time all. We want to reduce pressure and many hours work for that. So if you cast in sequence 3 or 4 layers, it shall be around 2 meters. Wall section shall be cast in layers after pouring approval is obtained. Curing shall be done conducted in accordance with requirements and approved procedures. And curing is very common activity, but very important, significant. You cannot avoid this. If you avoid this, you will destroy your concrete, in fact. Then I say, now we are talking of roof slab. Now, roof slab, in this case, we were talking of this section was, setting out walls. In this case, we studied, then you can say formwork of walls out of that. Now, vertical members have been done. So we are going to do roof slab. Roof slabs is very much important. Roof slab, which says is now another slab. You can say one slab was grade slab, then roof slab, grade suspended slab, because there's cellar basement. So roof slab. We're talking of, in this case, not very, very uneasy. It's the professional lecture. Roof slab. Now, because we are going to do roof slab, we need scaffolding. So scaffolding shall commence even as wall construction activities in progress. Simultaneously, if it permits, there's enough space, we can work on temporary provision, and that is scaffolding. Wherever it's completed, we can do that. Roof slab scaffolding shall base on provided proprietary design by its vendor, which provided arrangement shop drawings must have been approved. Means because it's heavy structure, suspended slab, it should be properly designed, and scaffolding supplier, vendor who provided us, who will provide us this material, provided us, that must have given us drawing to our requirement, and we have to follow that. We have to comply with those drawings, and material has come according to that. This must be remembered. That whatever material we got for that slab is according to that drawing. It's approved one, and we have to comply with that. That's roof slab construction joints are shown on attached sketch. Okay, that's different one. Means you must have every project, every different types. So now what says roof slab construction joints are shown on this drawing and should be complied with, and suspended kicker shall be placed for parapet wall by extending one side beam forms and other by fabrication of forms. All right, says for parapet. Now parapet is above roof. So now formwork setting out and level references shall be ensured meeting requirements. Reinforcing bars shall be placed on spacing set on formwork. In case certain building services inserts are required. Inserts means inserts are required in cast in concrete. Partly cast in concrete shall be arranged to be placed in. But in general, all electrical fittings on industrial projects should be surface mounted. That's okay for industrial projects to be surface mounted. Says in case certain building services inserts are required, shall be arranged to be placed in. But in general, all electrical fittings on industrial projects should be surface mounted. Once the slab preparatory works are ready, inspection shall be conducted for approval for pouring, and whoever is competent person in your company or consultancy, or whoever is authorized for this, or yourself may be authorized, so whole shall be inspected for purpose of pouring. Roof shall be poured following all steps and procedures required in line to approved procedures for slab pouring. Means there should be some method statement is approved for slab pours. In general one, we have to comply with that because that's the must, that's the mandate. After that, concrete samples shall be collected in line to QC procedures for site as well as laboratory testing, and whatever is that, slump test, temperature test, cubes, whatever is that, samples for purpose of testing, ensuring when it comes to you on site, concrete is delivered to site, not to location but to site, you take slump test and you conduct slump test, you conduct temperatures, air test, then you take cubes for testing all this. After doing this, for this curing immediately after finishing surface, you have poured concrete, finished surface, then you have to start curing, and post finishing shall be conducted continuously for defined curing period of 14 days. 14 days is just because spans are long, and maybe you are using GGBS nowadays. Scaffolding shall not be removed for 14 days and until full design strength of concrete is reached. Then cube shall be crushed on 7th, 14th and 28th days strength. Actually it is 7 and 28. You can also do on 14. It depends on the requirement. So you can say cube is procedure of code, general one. And you can say next stage is rainwater chutes shall be boxed out on parapet, wall, formwork, that's rainwater chutes, or you may call them inlets, outlets, and also some cases they call it gargoyles, which are not piped one, and it's not general. Then reinforcement shall be placed in concrete, cast in same manner, so as for main wall. Every pour be it a footing, footing pour or step column pour or wall or floor or roof shall be wet cured with Hessian cloth, covered with polythene sheet and kept wet for a minimum period of 14 days in accordance with the specification, in compliance and conformance to specification. For this, you may require some 5,000 liters capacity water tanks, 2 numbers or more, on elevated platforms shall be provided for round-clock curing operations. Approved curing compound shall be used in roof sockets, and equipment generally are excavator, JCB, transit mixer, crane. For this purpose, maybe if required, talking could be possible. So it's very interesting one, and we have so many stages covered in substation of this building. You can just see what I'm talking of. This long statement, of course, this is substation building. It is substation building, electrical building, you can say, as we defined in this case. We try to give you something in this. In general responsibilities, just go back just to be clear about that, or refreshing that. In this MS1 we said this is MS1 means general responsibilities. In this MS1, that's here MS1. In this case, we defined before definitions of titles. Generally, these are project site manager, construction site manager, construction superintendent or project supervising engineer, infrastructure superintendent, site engineer, geotechnical engineer, safety officer, general foreman, quality control surveyor, personal protective equipment. These are, these abbreviations. Project site manager means head in charge of site, who is responsible for all acts, procurement, execution, everything. It's like executive director of site, or project engineer, you may say. Project manager or project organizer can be said, means whatever title it is, but is responsible for everything. Then construction site manager is responsible for construction, what's going on site for all construction site, in charge, and supporting manager, and also director responsible too. Then superintendent means supervising certain areas in same capacity as construction site manager, but reduced responsibility. Then, of course, construction superintendent and infrastructure superintendent. There are so many superintendent for requirements. Then one superintendent may have 2 or 3 site engineers with them support. Here it's not site engineer in charge, it's site engineer. I'm saying site engineer in charge of something else. Means this in charge of some area only. But we are saying in charge of site. Site manager, you can say site organizer or construction manager. Construction organizer, the site in charge is equivalent. And then geotechnical engineer is responsible for soil mechanics of soil. Soil mechanics engineer, you can say soil engineer. Of course, not full-time present, but responsible for that, to see site investigation, site exploration, soil exploration, then backfill design, and then compaction related, testing related. So many issues, even in the available, even in laboratory, metal testing laboratory. Then of course safety officer, safety, very well, safety, health and environment system, for which safety is important, to comply by that. Then general foreman means foreman above foreman, responsible for resources provision to each site, how many workers to go to that site, how much machines are required on priority basis, to consider that. Then foreman, direct worker, direct force on site, who executes job through workmen, work people. And after the quality issue, means department where certified in the system to approve or disapprove, to direct means that person is of course paid by organization, but that person should be independent as far as quality status is concerned. Means that person should be is considered in every activity and should direct people if they make mistakes. It's a very important job, quality control. Then surveyor, of course, land surveyor, fixing coordinates, labels and all that, using theodolite, using elastomite, whatever. Then, of course, PP. So this was now responsibilities are, as I told you, these responsibilities are already given, and you can just detail out in reading. It's not a big issue, and it can be. I'll speak with this. It says, PSM shall ensure that involved activities are carried out in line with accordance to project specifications within specified time and within budget cost, since PSM is responsible contractually for project site prosecution on an overall basis. We can say PSM shall manage to procure all required resources for relevant activities. PSM shall control overall operations, respecting all activities in all respects, being an organization agent. CSM, construction manager of course, CSM shall arrange resources required accordingly and act overall responsible for excavation operation directly reporting to PSM. CS, superintendent shall control, monitor and direct site engineers, general foreman and workforce for relevant activities. G shall ensure that earthwork related activities are conducted in line according to project specifications and this method statement. Site engineer shall be responsible for all site activities and follow instructions of construction superintendent, construction manager. Whatever mishap or whatever mishap or on excavation operation, if it happens, shall be notified immediately to CM by site engineer for immediate action. It's required for either possible remedy or record for authority review, whatsoever case may be. And infrastructure superintendent, I shall ensure and all activities are carried out in line according to this method statement as well as complying with contract specifications, project specifications. General foreman shall be responsible for whole lot of workforce available on site for distribution, extraction of output, redeployment, supervision and control. This is extraction of output, that is one. Whole lot of workforce, GFM shall be responsible for whole lot of workforce available on site and site for distribution action, execution of output, and you can say redeployment, supervision and controls. GFM shall ensure that required workforce should be allotted to respective site every day during morning depending on various activities in which connection, a coordination, interaction with site engineers, supervisors, CMCS, etc. shall be required continuously. General foreman shall also ensure that required equipments are available on site during activities ongoing. GFM shall every day report all actions to CMCS and engineers. Foreman shall execute operations, deploying workforce and explain in full language work persons understand about all instructions and toolbox talks every day, ensuring that instructions are followed up by workforce regularly. QC shall inspect all operations required to be effected according to specifications and in line to inspection test plans requirements. Surveyor shall ensure that all surveys are conducted to requirements with all bench marks and grid coordinates located to requirement as well as all surveys records for submission. SO shall ensure that all safety requirements are complied with met by site personnel. EPC contractor shall conduct surveillance over all ongoing activities, that is EPC. Main contractor, you can say, shall conduct surveillance over all ongoing activities all days as well as ensure that inspections are conducted regularly by engineer or client. These are general, these are not, you can say, broad, the general points only we talked of. Every job description varies depending on organization or depending on project requirement. So it's only for purpose of guidance that some reports, some duties have been indicated, but it's not exactly. You have to describe in fact yourself about a project. In that case, safety we talked of is general, and then of course safety, then you can say we talked of, let us move a little on this better. just to refresh. Safety, which is very important part of every site prior to commencement of whatever activities, workforce shall receive start card or toolbox talks, very well explained. Process involving a particular safety risk shall be calculated by conducting job hazard assessment and necessary protective measures adopted to address risk issues. Now, included measures should comply with real requirement standards as accepted or recognized by industry or OSHA. All persons shall be imparted with regular job basis, safety lessons or training from time to time and record maintained. In this case, action has to be carried out on operating authority. In this case, activity has to be carried out on operating authority area. Therefore, all regulated precautions shall be strictly adhered to, affect full safety standard. Only specifically approved mechanical equipment, third party certified, whilst locating those services be used. Safety officers shall ensure that persons being inducted on site are well aware of adopting right suitable safety procedure to be implemented on site for activity concerned. All persons available upon site shall wear job required PPEs, personal protective equipments issued to them. Wherever activities pertinent to farm work are involved, sustainable supporting system shall be ensured. I'm talking about SO, that is safety officer shall ensure that persons being inducted on site are well aware of adopting right suitable safety procedure to be implemented on site for activity concerned. Then you see all persons available upon site shall wear job required PPEs issued to them. Wherever activities pertinent to farm work are involved, whenever you can say, let me just allow you to read if you can. No problem. All persons available upon site shall wear job required PPEs, and wherever activities pertinent to farm work are involved, sustainable supporting system shall be ensured. Sustainable supporting system shall be ensured adequately to transfer safety all imposed loads during preparatory work, pouring concrete, and where activities pertinent to farm work to support suspended slabs or other critical structures that may give rise to safety risk situation shall be required to be certified by a third party, which may be either system vendor's engineer or other person suitably qualified. So we have to do this again. It's a very important point here. We have to see this. Means wherever you can read that. Just a minute, please. Read on. I'm just coming. Hold on. I'm just sitting, relaxing, just sitting in place. Reading. Long sit. I'll come back to point 9. So wherever activities pertinent to formwork are involved, sustainable supporting system shall be ensured sufficient adequately to transfer safely all imposed loads during preparatory working pouring concrete. Now, where activities pertaining to formwork to support suspended slabs or other critical structures that may give rise to safety risk situation shall be required to be certified by a third party, which may be either system vendor's engineer or other person suitably qualified so to do. All significant formwork designs supported with required test calculations shall be proposed to engineer for approvals prior to installation. Hoisting of prefabricated formwork sites shall be raised using either tower crane or mobile crane, avoiding manual shifting. Scaffolding system shall be required to be installed at all locations where work start in addition to stepped ladders, working platforms and access ladders. Reinforcing bars shall also be prefabricated in yard to an extent possible. It should be raised or shifted to higher locations using cranes, avoiding manual shifting. General principles to shift as much materials as possible using mechanical means should be adopted rather than manual shifting to avoid accidents. During long moving activities, workers shall be allowed rest pauses to drink cold liquids or tea for refreshing, recharging. Then drinking water shall be available on site for consumption by all personnel. Dust storms shall not allow external work of whatever sort. High temperatures conditions shall not allow works in open to sky areas. And then no material shall be allowed to be shifted, mounted on workers' heads. This is very bad in our country. Still a lot of people carrying on their heads. Okay, then we can say that high temperatures conditions shall not allow works in open to sky areas. No, no material shall be allowed to be shifted, mounted on workers' heads. No workers shall be allowed to play with equipment. Quarreling on site shall not be permitted at any cost, at whatever cost. Maybe if people don't accept, we have to take action against them. And use of mobile phones by workers below foreman level or supervisor level shall not be allowed, shall be permitted. Site shall not be kept in untidy state or conditions by regularly removing all debris, garbage, and unrequired materials. No concrete transit mixer, no concrete transit mixture delivering RMC or ready mixed concrete on site shall be allowed to wash out transit mixer at site locations, but to only designated areas for that. There may be designated areas for disposing your concrete water after washing, and that must not be taken away. Then we say material shall be stocked on site areas if so required in such a way that circulation areas are kept. And you can say material shall be stocked on site areas if so required in such a way that circulation areas are not adversely impacted. No electrical cable shall be laid exposed and no domestic fittings be used. A qualified electrician must be on job all hours for look after and maintenance. In case of mishap, it is significant to ensure that the victim is immediately imparted with first aid and then transported to nearest hospital or medical center as convenient. No untagged scaffolding or ladder or other access device shall be used. All vehicles shall be parked only within designated locations. Hard hat safety zone areas shall be demarcated. Smoking zone designated toilets are provided, and on facilities, construction projects, emergencies procedures shall be explained to all concerned personnel to resort to actions as and when certain sites evacuation requirement arises. All personnel shall be transported by suitable vehicles when joining and leaving shifts. First aid box shall be available at all significant locations with known first aider person who is there. Then supervision, a competent inspector shall visit included area daily to assess safety measures adopted. Snags observed during visit shall be notified to supervisor present, who immediately would act to bring adopted safety measures to an acceptable standard. So this was just a brief of our statement we just had read, and this is what we studied for this. We studied in this, in this building of substation. We studied 8 stages and then 7 stages. We studied 8 stages for substation and then for base and foundations. So these stages are very significant from my point of view. Then you say stage 1, stage 2, stage 3, stage 4, like this 8. In 1 it's covered below ground, and that is earthwork, blinding, waterproofing, screed, protection up to defined elevation. Then footing pads construction including kicker, and also and stub columns, walls, stub walls, and then ground slab, then floor slab for main building, and wall construction up to bottom of roof, and then you can say ground slab, grade slab, ground slab, then you can say ground slab, HVAC room including anchor bolts and ladder, then floor slab for main building, wall construction up to bottom of roof slab, and roof slab construction. And you can say roof, floor slab, main building, and then roof slab and parapet walls. Likewise, you can read this. This is for transformer base. So in this transformer bay, Let's continue. I hope you have gone through this. Okay, we will follow on this. This is transformer bay and foundation are to be constructed in following sequence. Stage 1 earthwork, blinding, waterproofing, screed protection. Stage 2 footing, pad construction and kicker, 100 mm above top of footing, including water stop, water bar for transformer bay partition wall and boundary wall footings. Transformer bay partition wall full height of 10 meters, including casting incorporates for roof slab, roof truss. Transformer boundaries, transformer bay boundary wall, including cast in sleeves for fence post and transformer foundation base, including bases for slump and wall pit, gravel fill between foundations and walls, and steel roof truss and roof. So we have gone through this, your method, and now so you can read this. It's not very big deal. You read. It's also available on So let's now move further on this. Let's see. Let's see one by one. What can we do? What can be done on this? In this case, we had some, this is another statement. This is because the floor slab setup, not building floor slab. This is okay. This is what we are going to do now. Floor slab. In this sketch, you will not see some sketch. MS1 for general definition. So the MS1 we have seen is sketch 61 indicative only. Let us see. Sketch 61 indicative only. It will be 61. So 61 indicative only. Okay. 61. 61. 64, 61B, 61A, 61. Alright, this is our sketch. Grade 1, this 61. Just not going to read this sketch. In 5 minutes I'll be back. You can read this sketch meanwhile, no problem. This is just good one to read. might have seen now by now sketch. It's very important sketch. You might have seen this sketch correctly. This is 80 by 80 building. 80 by 80 meters. It can be anything, it doesn't matter. And you see these walls here alone. These are blast walls here. And this is access floor, raised floor. This side are offices. An emergency exit like that. This is wet area. In various positions. Blast doors, RCC columns and grids. And 5 meters between walls. And this is 555 and columns at 5 by 5, all columns. Peripheral blast walls, suspended ceilings. So columns are all there in this. All columns are there. Suspended slabs, roof slabs, raft foundation for additional safety. Blast doors made of steel. Plant controls from buildings. Only ventilators for wet areas. Comfortable circulation inside building. Height 8 meters. Got this point, and this is regarding. You can see this is regarding this here column side, which is not shown. This is a big area. Means 16 divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 by 16 divisions. 5 by 5 you take, and 256 divisions in this. This very important point. And it is a central control building. It is. This point is very important one. So you can say it's something very powerful building which shall take care of whole plant controls. It's that much. So we have to see that point into its. I'll read now what it says. Let's see. That's what it says in this case. Okay, now it says slab on grade. Sketch is a slab on grade level shall be casted over compacted fill. Title is floor slab. Only we are talking floor slab. So says slab on grade level shall be casted over compacted fill by using a separation polythene membrane. Slab is divided into two main portions. Lower level portion, whatever elevation, shall have a smooth level finish in order to receive basis of access panel system. So these are lower level, or you can say for raised floor, for computer servers, computer cables. This lower level which shall have raised floor system. This portion is to be cast in panels to give required joints according to drawings, and high level portion shall be cast in panels according to required joints. And surface finish for this section shall be rough, since tiling and flooring systems are to be applied. In electromechanical rooms, surface finish is required smooth to receive epoxy coating. Electromechanical rooms, surface finish is required smooth to receive epoxy coating finish as specified. General curing shall be carried out to rooms. General curing shall be carried out to norms of project specifications. All cable trenches and separating walls shall be cast up to levels and dimensions. All cable trenches and separating walls shall be cast up to levels and dimensions specified on related drawings. Compaction respecting backfill up to layer just below blending level. Approval of compaction by material testing laboratory in line accordance to specifications. Application of polythene sheet over compacted and prepared grade for soil isolation. Preparation for blinding concrete by leveling and clearing. Pouring blinding concrete to specification requirements over all areas. Preparation for grade slab activities for all areas. Fixing of compressed filler joints allowing polythene members. Fixing of compressed filler joints allowing polythene allowing polythene membrane to pass through between compressed filler and concrete block drought wall. Provision and laying of reinforcement, either including welded wire mesh or 8/10 mm reinforcing bars located at 150 to 200 mm center as decided all over between prepared joints locations supported with due concrete covers. Providing supporting chairs to laid reinforcement or fixing spaces as case may be. Inspection to be conducted for concrete pouring clearance. Arrange for concrete pouring and carry out it to specification compliance all over areas between construction joints. Where roughened surface is required, finish using wooden float followed by immediate and continuous curing. Where smooth surface is required, apply power float after suitable concrete surfaces obtained to accept power float or helicopter. We call it helicopter in cases because like that it works in a way helicopter works. In case no power float is required, smooth finish could be affected by steel float, which could later be either acid etched or scabbled or chipped out for latent removal. And equipment 50 ton crane, then flat bed trailer 40 tons, excavator backhoe, plate compactor, water tanker, and workforce, casting engineer, placing engineer, casting foreman, placing foreman, carpenters, steel fixers, masons, laborers, according to requirement. This was that. This one can say for this. I think it's some reasonable. We have to understand this. And next one is we have to just say. Then it was what I said. It should be, I think. Mortar for block work. Okay, we'll take up that. Let's see something else now. We are here in quality now. Construction statements, etc. We are going through. It is all, time consuming, but it's not easy to write. In fact, it's not easy to write. We say it's easy, but actually, in this case, it is mortar for block work. We will look after, and then seawater basin, baffle walls, concrete pours. This is a very important one in case. There's so many statements related to seawater basin. As we saw on that plan 20, sketch 20, the plan you viewed. It's a very important one point. So you can see that. This test is, 2BS 8007. This is seawater basin or whatever water retaining structure is required to be tested for water tightness. That's very important one. Right, test. So we don't jump directly into something. And there are, also we can say, we just go to statements again, we'll find that it's there. You can say, is that? Yeah, it's there. I will show you many sketches otherwise too. And that is, I say building plants, then it could be non-plant as well. If you see non-plant building also, we can just see. Hold on please, let me see how it works. Non-plant building. Let us just see how it works. It's important as well. Just in a place, let me do it so that I can understand. Serious is taking time. This is it's taking time. Meanwhile, it's taking time, so I'll go to something else. This takes some time. I don't know. A lot of time taking. Why? I think it's doing. I did my laptop. I did that time. Maybe it's not very speed given. It's not getting speed. I think I'll do it again. Better. Do it again. Anyhow, we'll see later, no problem. It's here, you can see this, no issue. You can see non-plant buildings here which we'll deal with. This will stay about blending concrete. Then we'll go to for receipt fabrication, storage after enforcement. It's an important point. Then we go to, I think this will better than this, block works of oak grade level, and also these buildings. It's very important one, this non-plant building. Plastering and rendering, block walls and RCC surfaces. Office system, I think it's better to take this already done. I think I'll take this one better than laying cement floor tiles. Let me put this off better. So we'll take that one better than it's already there. We can say building drainage system. I think we'll take this one, floor screed, then you can say concrete interlocking blocks, roadworks and driveways. I can say preparatory works pertaining reinforcement placement. Then you can say pouring concrete, post concrete repair, sewage pipeline laying. Okay. I think that's all. In this case, it's better to go through this as well. It's not bad idea. Means this will give us some input here as well. This is not bad, and I think this will be input. So let's see. Control S if I do, shall it work? You can see it shall work or no. It's not giving us. So in this case, you'll see blending concrete is an important idea, and we have gone through that. We'll see all this in next time here. Only 35 pages, I think it's better than non. But then blast building, or this process building, or you can say plant buildings. So we have to take this point in consideration here. This all you can say. You can add many more parameters, points to this at later stage, because all are related. Quality have to achieve, and quality based on designs. Quality we have to achieve, that is required designs. Maybe it's not given sometimes on designs what we have to do, but to obtain right design on site itself is based on quality, and designs are converted to construction plus, and that's based on many method statements, and which relate to exact time, cost and risk we involve, time it takes, and cost it consumes, and let's say time, cost and risks versus the other here, and risks are reliability plus, then we have to conduct all this based on analysis and synthesis, and we'll expand this circuit also, how we can say this can be done. It's in fact you can say, it's in fact a kind of system. You may say we work for system, and this system is a logical one. According to statements we do, logical one. We cannot simply say no. We have to do according to logic, according to what we say. We have to currently understand this. So we say all this when we say this quality, building non-plant, building plant, all are different types, building non-plant, building plants. So we can say, meanwhile, before closing down all this, we have to understand actually how we can relate this. Don't feel upset with this. After all, it is quality that we have to achieve, and quality achieved on designs, and designs means construction, and construction means you have to devise method statements to make sure that time cost is valued and risks are made reliable results, made reliable sources. Risks you can say are converted to power of reliability based on analysis and thesis. That's very much you can say, and we can add anything to that. It's not a big deal. So we can say something to create or not, something like that. You have to understand everything. It's big big statement I'm making, that don't avoid work. Sorry, cold. Don't avoid work, because it's work that shall make you. It's work that shall work for you. It's nothing else. Engineering is work. And if you want to avoid work, you cannot survive. You cannot forget survival. You have to move. You have to move in every way. And that's where engineering works. Engineering designs or works. Engineering moves. And if you want to stay in engineering, you have to lead yourself. You have to lead those. You have to lead in quality. You have to lead in designs. You have to lead in method statements. You have to lead in construction, because you lead in method statements. These are two clubbed one, construction plus method statements. If you know method statements, nobody can beat you. Only problem is you don't have experience. You don't exactly know what is right or what's wrong, how to do it. Every point counts in construction. Every point counts in construction. And if you do systematically agreed on method statements, you will be best engineer who can give quality of construction methods, and best one to convert designs to construction, therefore design and construction plus. Then of course management organization ability you will have, and analysis and synthesis is your power that gives you whatever you wish. And if you want this power, you have to work hard, really. In fact, you cannot say no. No is not acceptable here. We have to think that way. That's where we have to work with. It's a very important point. I'm going to close this after a few minutes, because I'm going to close it soon. Around 3 hours have gone. Disregard. This, of course, important is that chapter 3 is saying the statements, safety disciplines, all that we will review. We will see how this works. It's also an important one. So I can say we'll put this off as well, and we'll can say this point, and here we have to think of this. We have to put this file on again, URLs. We'll see how it works. We'll see. You can say that point. Let us now move on to close our talk. That is, this talk will be seeing later on. Now, I hope you got it, moved in. I think I cannot move any further because of my problem with computer. I cannot force on this computer unlimitedly.